Okay, it's noontime. We'll get started. Today we'll be starting the Unit 2, the programming paradigms. We will have several chapters on programming paradigms, and then today we will be starting with the first programming paradigm, imperative programming. So we'll talk about what is programming paradigm, and we'll talk about what is imperative programming paradigm, and we are going to talk about structured programming, stack diagram, call and return sequence, the prologue and epilogue. Okay, we'll talk about the prologue and epilogue. Hi, how are you? Hear me? Hello, hear me? Okay, so first I would like to talk about programming paradigm. So the first unit, the chapter 2, 3, we are talking about the memory models. That's about data structure and the data type, inference. Now in this unit 2, we start to talk about the program structure or control mechanisms. And then we have to talk about programming paradigm. Different programming paradigm would actually produce different programming languages. So when we design the programming language or any kind of language or any kind of language model, you have to adopt certain kind of the paradigm. Okay, certain kind of paradigm. That's the way that your language works. So we have imperative programming, structured programming, procedural programming. So initially, we have procedural programming. That means you have function code or you go to a certain code sections. And then later, the idea of structured programming being introduced, actually it start to have the selection, the partition, those kind of program structure. And then later, imperative programming, the bigger paradigm being created, including object-oriented programming or functional programming, different kind of feature being added to the so-called structural programming. So overall, it becomes a new category called imperative programming. So when you do, you have the procedural code, you have a function code, you can go tree structures evaluation, you can go two-dimensional iteration, traversal, you can go linked list procedure. Okay, so there are a lot of different kind of storage way. And then in terms of the imperative programming, there is traditional structured programming, and then object-oriented programming, event-driven programming. Okay, these are different programming paradigm under the imperative programming. And object-oriented programming, including the encapsulation, inheritance, polymorphism, and abstraction. We'll talk about this next week for the object-oriented programming. And that's a second programming paradigm within in the imperative programming. The first programming paradigm is the structured programming. Okay. Imperative programming. So we also have the object-oriented programming, and object-oriented programming including writing every call or every data in the object format. Okay, in the object format, and then have the data encapsulation. You keep your data inside the object, and then you have iteration interface purely using the iteration interface. Okay, so basically, object-oriented programming was very successful for a long time, especially for graphic user interface. But object-oriented programming nowadays seems to be a little bit too much for the AI age. Okay. Event-driven programming is on top of object-oriented programming, and it actually creates an event. An event is actually one kind of object, and then there is an event queue to handle the event. And that is a special kind of object-oriented programming, and it's added on top of the object-oriented programming to help the graphic user interface. So you need to know about event source, event object, okay, event handler, and event loop. These different things you need to know, okay, what is event driven programming. So we have a mouse click, that's an event. And then you have a event handler that would actually say drag and drop of your windows. That actually is event handler. And then that event handler, that event object created when you click the mouse, then the object was put into the event loop, and then event loop start to process one by one. Once the event loop run on your event object, then they will get your event handler to handle your event. Okay. So this is the idea of event-driven programming. But event-driven programming is considered to be a feature on top of object-oriented programming for graphic user interface. And this next one is another programming paradigm called concurrent programming, multi-threading or multiprocessing. This one in our course, we do not cover the concurrent programming, and it is supposed to be another course on parallel processing or multi-programming course, okay? And Java has very good multi-threading packages. And the next one is a functional programming. So three major imperative programming paradigm. That is structured programming, object-oriented programming, and functional programming. Okay. And functional programming is write a program based on function calls. So function calling function. That is the purpose. That is the program structure. But to support the functional programming, you should have these different features: referential, transparency, functional decomposition, pure functions, refactoring, higher order function currying, and immutabilities. So these are different features of the functional programming. And functional programming was proven to be a good programming paradigm at the AI age because it's helping the large reasoning to be faster, and you can make the functional programming well on the GPU or the ASIC to process the AI programs. So there are two major branches of programming paradigm: imperative programming and declarative programming. Okay. So most of the language nowadays, the commercial one, are imperative. Imperative are actually commands. It manipulates state of system and variables. Okay, and then there are many side effects because their function call or their program may not be atomic, so they may have many side effects. Okay, and the variable will be mutable variables. Okay, and then they use instruction after instruction, if then else, and loops for the control flow. Then declarative programming paradigm usually doesn't use the control flow. It actually using the data flow or using the function call. Using the logic reasoning reference inferencing engine to run the program. It's usually not by the manual machine models. Okay, so there is no side effect because actually usually a line of code is atomic. They don't have side effect on the other functional code, and there is no mutable variables. So declarative language usually in the old days is believed to be more suitable for the AI. So Lisp language, logic programming language, Prolog were invented to actually as the declarative language. Okay. But later proven that they are not convenient in terms of making the program work with the other problem. Okay, so basically nowadays, the mainstream for the AI language would be imperative programming with functional programming. Okay. So in parallel programming paradigm, basically based on the modular machine structure that has a memory and CPU. Okay, so this is the modular machine model. Okay, first we are going to talk about sequential programming. So sequential programming is you have the control flow. So imperative programming follow the control flow. So this chapter we are talking about the programming structure of the language. Okay, so you have the selection, the partition, function call. These are basic and sequential. Okay, these are the basic feature of the control flow. And then you may have jump or branch or go to function. But nowadays, people don't like to use the go to statements. Okay, don't like it. So basically, up to here, you may also have a recursive and functional programming. So these are the basic feature of the all days structured programming. Okay, structured programming. And then you add in the concurrency control, exceptional handling, and then also class definition, then you become object-oriented programming. Okay. So these are the basic features for the control flows. So in this chapter, we primarily will cover these different different features. Okay. So I believe that most of the features you know, so we just focus on the something that you may not know. So this sequencing go to, I think these are simple. Okay, this is a comparison for the C++ go to. And assembly jump. That just to tell you that when you have a go to statement, how it will be implemented in assembly code. Okay, this one. Okay, next one is the branch. Okay, there are a lot of instruction. So we talk about instruction just because that if you write a program closer to the assembly code, then they will have the instruction set to support you. Then the compiler will be easier to create code. Okay. So here is one way to write a program with the jump equal. And then this one is jump less than. Okay, let's use these two different instruction. And the next one is the expression evaluation, true or false evaluation. Okay, it's so expression evaluation. You need to basically know about infix evaluation, postfix evaluation, prefix evaluation. Okay. So when you write the expression, you have A plus B, the operator in the middle, this one is called infix operation, okay, infix expression. So if you write AB plus, the operator is at the end, this one called postfix expression. If you have plus AB, then this is called prefix prefix expression, okay? You need to know which one it is. Okay, next one you need to know about the expression evaluation, how they are done. Okay, this one I think is easy. Okay, this one I think is easy. Okay, next one is the orthogonality. Feature that can be used in any combination. This one, this is called orthogonality. Okay. Okay. So this is a large expression. Okay. I see. This one I think is okay. Side effect, several language outlaw the side effect. Okay, so basically the side effect is that when you have a function or you have any something, they may have a side effect on the program. That's not what you expected. That's called side effect. Okay, so here you have X sector, but you declare X outside, so you assign N to X, so you actually have a side effect of modifying this X. Since you declare X is global, so it's this X. So you assign N, you are supposed to uh, run N, but it actually set the X. Okay, it set the X. This is called side effect. Okay, control structure selection. So selection is if then else. I think this one you know that programming languages are not too hard. So we have sequential programming, conditional statement, if then else, and also the loop. This is called repetition. So this one, I think the most important part is the dangling if. You need to know about what is dangling if. And another one is the short circuit evaluation. Okay. So they might have if else if. So this one equivalent to else if. Not every language has this else if. This one in Python, yes, but not some other language doesn't have this. Some have it. So next one is controls loop structures. Loop structure, you have while loop, do while loop, for loop, and for each loop. So you need to know about each different type of loop. So first one is the while loop. Okay, I think this one is lowercase. Okay, this one is lowercase, sorry. So basically you know about the exit condition. So only thing that you need to know about while loop is that if this condition is A and you get out of while loop, the condition that you actually will guarantee right here is A bar, because only when A bar you get out of the loop. Okay, so this A bar must be true. That's what you design the loop. For loop is a special kind of the while loop. So the initial condition, if you put this one in this initial condition, put the I increase in the update condition, then you will have a new, you will have a for loop, and that put the initial condition right here, update statement over here. And then this one, the same while condition, then for loop is equivalent to a for loop, okay? So this is a for loop. And then this one is for each loop. For each loop is that for each loop, to make the for each loop work, you must have a new concept called iterator. Okay. So usually for each is like you have to put your language to have the iterable object over here. So this range function create a sequence, and this sequence is iterable. So you must make the object or container to be iterable. And then they must have an iterator that you can iterate through each of the object. So every time you retrieve a new object here. Okay, so this is traditional. This is for each loop. The left-hand side is traditional programming. You traditional for loop. 哎，Nick, how are you? Okay, so these are different loop. Okay, you can study, nothing important. Okay, so next one you need to know about what is iterable, what is iterator, and what is generator. Okay, so iterable is a feature for a object of object. So or a container. So iterable usually is in the Java, it actually is an interface. So it's some sort of function code that associated with it's iterable. So iterable usually has a three function that is has next function, and the remove function. Okay. These are the functions for iterator. I'm sorry, these are functions for iterator. And iterable must have an iterator. So iterable usually have a iterator for those containers. So iterator is a pointer. So if you have your data is iterable, say you have a list that is iterable, that means that you are able to go on this data sequentially, following the pointer one by one. If your data structure is a tree, but somehow you make the iterator being able to traverse through each node one by one, then you can also have a iterator. Then you are also iterable. So basically, iterable must have a iterator, and the iterator must have at least these three functions. Okay, so this iterable is an interface. It is some sort of capability. Your data can be counted or can be traversed in a sequential format. We call it iterable. An iterator is the pointer. It is the pointer, and that pointer may have the next function and may move to the next function, may remove some object. Okay, so these are the features of the iterable. Any questions so far? Any questions so far? Next one is the generator, and generator is on top of the iterator. So iterator is on top of iterable. So generator is more advanced. A function that can generate data one by one, and then performing similar to iterator is called generator. Okay, so these are the when you study Python, Python has this feature of everything. Okay, and Java you have this and this, no generator. Okay, so that's why we pick Python for as an example right here. So basically, this diagram tell you what it is. Okay, so basically, you may have a container that's called this. This one is a set, and then it produce a container that's actually a set or a list. And then this set may be iterable because you have pointer that can point it to it. So you maybe is iterable. So when you have an iterable, you must have an iterator. Iterator has the next function. Okay. And then this function is iterable, create an iterator. And iterator has a next function so you can point into the next some object. Okay. And then generator usually is a function that can generate the iterator. So it's always is relationship, and iterator is always is iterable. Okay. So iterable is bigger, iterator is here, generator is here, using function to generate it. Okay. So it's a generator expression that is a generator can create a sequence of a data that's called generator. Okay. And you can have a generator expression or generator function. So this chart tell you what is iterable, what is iterator, what is generator. Okay. So container, this is set dictionary tuple. Okay, these are containers. We talk about it in the data types. So you have double quote, for string, parenthesis for tuple, bracket for list, curly brace for set, curly brace key value pair for dictionary. Okay, and all of these are iterable. That means you can put on the for each loop. Iterable, as said, most containers are also iterable. Mostly, not everyone, but mostly are iterable. So they have an iterator. They can be traversed one by one. Okay, and what it is. So the following one show you how to create an iterator and also showing you how to use it. This is relationship when you have iterable and using iterator to access every data. Okay. And your for each loop to work, this X must be iterable. That means that it must have an iterator that can iterate through the whole data. Okay, here a lot of things to tell you how to design the iterator inside a class. Okay, different kind of iterator. Then next one is the generator. So finally, we arrive at the destination. The generator are the obviously favorite feature. A generator is a special kind of iterator. It's one kind of special. It's using function to generate the data. So a generator allow you to write iterator like a Fibonacci sequence, but in an elegant syntax, okay, with the iter function and next methods. Okay, so any generator is also an iterator. Any generator, therefore, is a factory to produce value. So factory means it also is a function that will create value in sequential format. That's called generator. Okay. Okay, generator, let's go back. Generator is a iterator that we talk about it. And generator had two kinds, generator expression and generator function. So it can be an expression, can be a function. Okay, it's a so from outside, an iterator is a lazy factory, okay, that is idle until you ask for a value. Okay, let's so here show you the generating function. You have a Fibonacci function. Your initial value is 0, 1. So you get a value, you actually get a value, and then previous and current are 0, 1, and then you go to 1, 2. 1, 2, you get a value, you get another one. So this one eventually will give you such a Fibonacci sequence. And in fact, you are using function to call it. So this function can be called generating function. So far, okay? So the returning value is using this yield. It's not return. Return means that the function finished. Yield means that you get the value and you will go to the next. Get the value, you will go to the next. So this is a function performed like with an iterator. That's called generative function. Okay. Any questions so far? No? No questions? Okay, so the trick is on this keyword called yield. Okay, yield. So the following chapter talking about this yield thing. Okay, whatever. So this is the relationship of generator, iterator, and iterable. Okay, generator, I think in the traditional programming is not that important, but when you go to some AI, okay, generator become very interesting, okay? So here, tell you what is comprehensive generators. This is generator expression, okay, generator expression. Okay, so this we finish the the talk about iterator, iterable, iterator and generator. And this is a new feature. If we go back to the control structure, it is not listed right here. So it actually is some sort of a new feature. You can put it over here for the iterators. It means that you can think about it as a pointer management. Okay. Iterators return value is a pointer. Okay, so it actually is kind of like a pointer management. And it's the new feature in the modern language. So next one, you go to the control structure 3 functions. So talk about function. So function is used for the abstraction. So you have the calling of the function and return of the function. Okay, so the advantage is modularization, call reuse, packaging, teamwork, abstraction with the okay, you can try to understand it, okay? And then there are set of rules. You have a code section, subroutine, procedure, operation, function, method, and lambda expression. These are all different kind of the function. Code segment is in the old day, you may have a certain section and you write the code here, and later people can call you, come here and then call back. Okay, it's similar to go to, but it do have a code segment, okay, in the old day. And subroutine is you have a main routine, you go to some subroutine and then come back, okay? A procedure usually is a name for a function without return value. We call it procedure. Function is with return value, okay? Operation usually is a expression, a op, okay? So it's a minor or smaller function, okay? We call it operation. Method is a function in object-oriented programming. Okay, so it actually associated with object. Lambda expression is anonymous function, a function without name. Okay, anonymous, anonymous. Okay, a function without name called lambda expression. So these are different names for functions, and some with special definitions. So these has special definitions. Some actually are similar or the same. Okay, so this is how the control being transferred to the subroutine and then come back. Okay. One thing that we do not cover here is a concurrency. Okay, the concurrency. That can be a different chapter or a different course for parallel processing. Okay, and then we have function. Function usually have input and create output. Okay, that's a function. So here define the function signature, function name, function parameter, list, return type. This return type is only a hint. So if you don't write it, it still work. Not a required one. Okay, whatever. And then you need to understand what is call stack. Call stack make the so-called function call possible because you need to create different reference environment, and then call stack is buffering the different parameters and local variables. And then once you finish it, the code frame will be dumped. Okay, will be dumped. So call stack is the basic idea of the function code. Okay, you need to understand what it is. Next one is exception. Exception is a special kind of function call. When your function, when your operation fail, then you provide a cure to bypass the error that we call it exceptional handling. Okay, so they are problem occur, creating exception object, throwing exception object, and handling exception. So this procedure of the handling the exception is similar to the event handling event-driven programming. Okay, it's event source, event object, event queue, and event handling. Okay, this event handler. So exception similar, you have exception source, exception object, throw exception, and then exception handler. Okay, similar thing. Okay, so in Python, you will try except statement. Try is the try, you will evaluate whether you will create the exception. Is exception created, you will jump to the exception handler. Next one is recursion. Recursion is function calling itself is called recursion. And recursion is especially important when we go to the functional programming later. Okay, so you need to understand how recursion occur. And here we don't teach you how to write recursive program, but if you are interested, you can go different places to play around it, especially CodingBet. Okay, CodingBet has a very good set of the recursive training functions for Java. Okay. Tail recursion. We have recursive code, but if you do more operation after a function, then that's not tail recursion. So tail recursion is a function without extra operation after you return the code. Then this is called tail recursion. So tail recursion is a good feature so that your compiler can optimize your code to be faster, and it can be as fast as the so-called iterative kind of programs. Okay, so here we do have a this one. Let's see. This one is pure recursion, and this is tail recursive. Okay, and you can also write in different way. Okay, it's two way to write recursion. And this one is faster. This one is using Euclidean algorithm. This one is using the deductive. Okay, so GCD1 is faster than GCD2. Okay, tail recursion main difference is you don't have extra operation after the function return. Okay. Okay, here we do have a GCD3 and 4. They are written in the while loop, not recursive code. Okay, so this is similar function. Okay, sometimes recursive is not efficient if you write the Fibonacci function. This one it will take exponential time to compute it, so that's actually not good. Okay, that's actually not good. But the same program can be written in iterative function, so that actually would be faster. So you can use a while loop to replace it. Okay, so this one will be much faster. This two, let me show you the complexity. So this one, if you have a Fibonacci function, you use this recursive code, you will have F5 calling F3, F4, and F3. F3 calling F2 and F1. F2 calling F1 and F0. F4 calling F3 and F2. F2 calling F1 and F0. F3 calling F2 and F1. F2 call F1 and F0. So these are the total function call you will need to have it. So it very clearly it would be exponential time. Okay, it will be exponential time. Okay, so that's exponential. But if you do this while loop operation, your F2 equals F1 plus F0. So you know about F2 now. So you actually ship this data over here. Then you create F3. And then you ship the data here. You create F4, F3 and F2 that will create F4. So this one actually, if you run this while loop for Fibonacci number, is the order of n. So it's way faster than the recursive code. And why people always teach you recursion using Fibonacci function? That's just for fun. That's just for fun. For real world calculation, it actually is wasting time. A better way to write a program is this iterative code. Okay, now I prove to you why this one's order of exponential time. This one's order n. Any questions so far? Hello, any questions so far? No question? So in the first project one, our purpose want you to work on the so-called sorting of different flavor, and that you to create a chart to analyze how it grows. So basically that one is to help you to analyze the growth rate. And growth rate order of n log n, order of n squared, or order of 2 to the power n. Order of 2 to the power n is not polynomial time, so it's an NP problem. When your problem becomes NP problem, then actually it is not trackable, too slow, okay, too slow. So that's the purpose of why our project one is on the performance evaluation of the functions, okay? No matter what important algorithm or program structure you have, if it is slow, no one will use it, okay? No one will use it. So here we show you two Fibonacci functions code, and this one is much better. This one is the order of n. Okay, so don't write this one. This one is only for fun, only for the textbook to teach you what is recursion. Okay, next one you need to know about the memory model, the stack. Okay, stack in the memory. This one you can study it. Okay, not hard. So should be fine. So you need to know about what is stack, what is heap. Okay, these two things, when you go to the compiler, you will need it. Okay, and stack also do bookkeeping. Okay, these are the value they store in the corporate. Okay, in the corporate. So when you call a function, you need to prepare your corporate. That's called prologue. When you return, it's actually called epilogue. So there's some fill-in problem. I expect answer like this, okay? So someone write something else, you will not get it right, okay? So this is prologue, you can write as prologue. But if you put GUE, should be fine, okay, should be fine. Epilogue the same. Okay, this tell you what prologue work do and what epilogue do. And then what inside a code frame. Okay, coder, code save. Okay, this when you go to the compiler and then you try to create code, you need to understand this code save, coder save. Okay. And then this is the register file to handle the coder code save, coder save. Okay. Register file. And you need to know about the circular buffer in the RISC machine for register window, how to share it to optimize the code return structure. Okay, similar. And then low-level virtual memory. Okay, you need to know about low-level virtual machine. Low-level virtual machine help your machine to be platform independent. So you can compile to low-level virtual machine, and low-level machine can run on different kind of machine, okay? This helps C to become a much more platform independent. Okay, whatever. Okay, we finished chapter 4. Any questions so far? Hello, any questions so far? No?
No, we're good.
Yeah, so any question about the project or anything else?
Yes, I just wanna confirm because I was still working on the last homework, and I remember you said that you accept late homeworks, right?
Yeah.
And projects.
Mm-hmm.
Okay, thank you.
I accept late for homework as long as you submit before the last week. So last week is somewhere in May, whatever May, whatever, I don't remember what day, but
Right.
maybe May 10th or something. Okay, this I'm not sure. Okay, but if Friday you finish the course, and then we give you the Sunday night, the midnight. That's the last time we are due for anything. Any homework you are super late, I will still grade it. But if you pass the Sunday night, Sunday midnight, then I cannot accept it. Other than that, there's no other rule.
Right.
Except for if you are late for more than 2 weeks, then I may give you a minor deduction, but not a major one.
Okay.
Okay, maybe 10 point off, maybe. Okay, because this actually makes sure people were still willing to submit early. Okay.
Right.
Yeah, but if you really have to be late, it's okay. 10 point is not really will not kill you based on our 5,000 point structure. It won't. Any question?
That's my only question.
So this course, I try to basically make it a very, very flexible course. So you can take it at any time. So most of the teaching material we pre-recorded. Okay. But if you have any question, let me know. Usually you reach me on the Facebook, that's faster. I will answer you within a day, for sure within a day. Email maybe not, because email, I'm not a full-time employee of Louis University. So I may check it from time to time, maybe 2-3 days later. So it's not the most efficient way to reach me, okay?
All right.
Okay, if no question, that's it for today, okay? See you next time, bye-bye.
Thank you, bye-bye.
Thank you. Have a good one.
Bye-bye.